Good. So hi everyone. Welcome back to our second session of the day. So today on this session, we're going to take a look at data profiling, what data profiling is, and some common techniques that we can use to profile. Uh, we're going to also be seeing data exploration or EDA. So there's an echo. Okay, let me change. So okay, what I want now? Is it better? Not now? Uh, can you guys hear me now? Is it better? Is it audible? I think there was an echo. Fozia? Okay, maybe for Fozia, it's on your side. Can you check? Okay, I don't know what's going on. Maybe some of you it's clear, for the others not clear. Maybe it's your audio. Okay, let's try this actually. Okay, is it better? Yes, I will share. I just wanted to see if my audio is clear. Is it better, my audio? Can you hear me better now? Okay. For those of you who are having issues, is it better? Stefanos and others. Okay, good. Okay. 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 Okay, so let's start. I don't know about the echo, where it's coming from, but okay, let's start if it is manageable. Let's start. So yeah. So we will see also EDA or some data exploration techniques as well, and some examples or demo. So if you have a question, just raise your hands or write them in the message, and I will make sure to just get back to you on those. Okay. Okay. Let me share. Can you see my screen? Okay, good. Yes, Surafil. Okay. Good.
Yeah, it's working.
Okay, thank you. So data profiling and exploratory data analysis or EDA techniques. So we're going to be taking a look at this, and we will also see some examples related to, actually, I'm going to be using one of the most, or one of the, not the most, well-known data set, which is the artist data set, which is the data set on flowers. So we will also be having a demo session on those on that specific data set as well for this session. Okay, so let's start. So let's start with what data profiling is. So data profiling is just a systematic process to examine the data set's structure. What is its structure? How many rows? How many columns does it have? The content, what type of content is it? Is it numeric, or is it object, or qualitative and quantitative columns, and the quality? So the quality means just the distribution of the data, the values of the data. That's one thing to check the quality, and the second one is the number of missing values or null values. So with data profiling, we are going to examine these things, and it involves assessing data types, identifying missing values, and computing basic statistics, which means the mean, the median, the mode, and so on, to ensure data is reliable. So one example, it could be checking if a column of measurement is numeric or object, or it contains errors like text entries and so on. And the key output that you're going to be looking at when you are doing or performing data profiling is the data type. What type of data is it? Is it numeric? Is it object? The distribution, then if it has any null or missing values, and how many are there, if there are any, and take a look or find out if there are any duplicated rows, and just do some basic correlations. So this matters in order to this will help you detect early, detect the quality, any quality issues it may have, and prevent any downstream errors that you could have later on. So this is really basic and really core when you are doing data analysis, data science, and so on. So if you got a question, I think someone has their mic open. Okay, maybe it was just a mistake. Okay, so let's come to EDA. So this is also a very basic, and one of the first things that you should do. So is data profiling and EDA. So EDA is just an approach to visualize and analyze data to uncover patterns, trends, anomalies, and relationships. So when we come to EDA, we look for hidden patterns or trends or a relationship that might not be easily detectable with just taking a look at the data set. So this includes plotting a time series of to identify seasonal trends. So of course we're going to be taking a look at these things further on in the future, but it will help us identify seasonalities, trends, and so on. And scatter plots also helps us to see the relationships, and heat maps also will help us see the relationships between two or more values or columns. So why is it important? So profiling, or the earlier one that we saw, it ensures that the data is clean and sustainable for analysis, which prevents errors in the downstream. But EDA reveals insight that will inform us in the modeling, decision making, and hypothesis generation. So by depending on your EDA, you're going to be deciding on your modeling, deciding on your strategies that you should follow, and in order, it will also help you to generate hypotheses. So, for example, profiling might reveal that 10% of the value is missing in a key column, while EDA shows a strong correlation between two variables. So, profiling is just to show or to identify if the data is clean or if it has any issues, and while EDA is there to show, uncover patterns, trends, correlations, and relationships. So what you could expect, or the key benefits from EDA could be improved data quality by identifying issues earlier, guides the feature selection for machine learning when you select it, and enhances communication through visualization. So you're going to be using these visualizations in order to explain to your stakeholders. Yeah. Okay. So first, we're going to be taking a look at 5 data profiling techniques, and then we're going to go to the EDA techniques and take a look at them. So, sorry, I didn't say this. So what I would suggest is that we take a look at the theoretical part for data profiling techniques, and side by side we take a look at the demo, and then we will move on to the EDA and take a look at the demo as well. So it's one file, but we can, I think, classify it to those. Okay. So for data profiling techniques, the main, I would say, your go-to would be these two, which is summary statistics, which is by using pandas describe method. So it computes things like mean, median, standard deviation, maximum, minimal values, and quartiles, which means how many of the values stand above 25%, above the 75% on the 50% scale, and so on. So of course, this works for the numeric columns by using describe methods that's found in pandas. For example, for a column of sales data, the mean of 100 and the maximum of 10,000 might indicate outliers. So outliers means, so we will see how we can identify outliers and how we can actually clean them. Okay. So the purpose of using statistical summary is a quick overview of the data distribution, but the cons, of course, include that you miss the categorical and it's just for temporal patterns. So for categorical or object type datasets, it's not going to work. Of course, you can quantify them, or you can use dummies method in pandas in order to assign numerical values for the categorical column, and then do this statistical summary, but it doesn't work directly. So that's one drawback it has. And missing value detection is just for identifying the missing values. You can use is NA or is none method that's found in pandas as well to calculate the missing percentage values. For example, a column with 20% missing might need imputation. Of course, this does. So one thing that I would want to highlight or to emphasize is that so identifying errors in a data set and cleaning or coming up with a strategy to clean them is a two very different things. So so here 20% missing value is just identifying it, and applying imputation is a strategy in order to account for this error, right? But of course, imputation cannot or is not always the best strategy to do so. Okay, so you need to have a deeper understanding about the data set. What does none mean for that data set? What does zero mean for that data set? Should you leave it alone? Should you make it zero? Should you apply values, and so on and so on? It's a very different strategic thinking. So in order to understand the value, you need to understand what it means. You need to understand what non-value represents for that specific column, and come up with a strategy. Okay, so one of the strategies, of course, imputation. Of course, there are a lot actually. Like for imputation, of course, you have forward filling, backward filling, filling in the mean value, filling in the mode value. You could also do that, or just making it zero is also one option, and so on. So you need to choose what to do by depending on your knowledge about the business, your knowledge about things, and so on. So okay, I don't want to go off our course, but for example, for your current data set, have you identified anything that's out of the ordinary? If you do so, what did you see, and what kind of strategies are you thinking about, or why do you think that errors are happening? So you need to answer these questions for yourself. Of course, at the end of the session, if we have time, we can also discuss it. But please try to adapt this kind of mentality when it comes to working with data. But of course, if most of the data points are missing, for example, 80% moving, would of course recommend just removing the whole column as a whole. So alternative, checking implicit missing values. For example, you you can check for zeros or NA strings and so on. Okay, sorry. And the other thing for data profiling is checking the type of the data. So you can do this. You can do this by using the f.d types, which is data types, to ensure they match your expectation. If you already have an expectation, so some common pitfalls could be incorrect types could cause errors in calculation and visualization in the future. So you need to do this as well. And of course, the distribution analysis, of course, this can also be part of the EDA part, which includes using histogram, frequency table, understanding variability distributions, and so on. So, of course, this is just basic statistics, actually. And the histogram of customer of age, the age of the customers might show a skewed distribution. So skewness, is it left skewed, is it right skewed, and what does it mean? Or is it normally distributed? So by depending on your analysis, you could come up with a strategy in order to fix this. And cardinality and uniqueness, how unique. So checking the number of unique values in the categorical columns to assess how diverse they are. So categorical column with only one unique value is not informative. So if you only have one, for example, for Kifiya, if everyone is from Ethiopia, and the categorical value for nationality, if it is all for Ethiopia, is not going to give us any information, right? So everyone is from Ethiopia, so we do not need to visualize it or do anything with it. But if there are unique values, so that might be interesting. So this is what it means. Okay, like as we have discussed, let me go to the example, and I think we can take a look. So here I have chosen to work with Iris. So you can take a look at, you can take a look at Iris dataset. So here you can take a look at the dataset, what it means, what it represents. So it's just for flowers. So it has ID spiral length, which is a green leaf that you see. And the petal length is just the colorful part of the flower. So here is just represents the lengths and the widths for these things and the species. So we have 4 species. So that's just what it represents. So 3 species, I'm sorry. So Iris, I think, Setosa, this one, that one. So the names are scientific, so I'm not going to go into them. So you can take a look at this. So we are going to be working with this data set, okay? Okay, so so this is just importing the dependencies. So here I have pandas, NumPy, Seaborn for getting the data set and for some visualizations, and Matplotlib for plotting, and SciPy for statistics. Okay. So here, the first thing that I did was we can actually run it together since it's not that intensive. Okay. So this is just loading the dependencies, and once you load the dependencies, I'm going to load the data set. We can actually take a look at the data set head. Let's say 10. So this is the top 10 values of the dataset. So here you can see the septal length, which is the green part, the green leaf of the flower, its widths, and the pental, which is the colorful part of the flower, its length and its widths, and the species. So we have 3 species. So this is the dataset that we're going to be working with. So this is the first thing that we were talking about, which is summary statistics and the missing value report. So for the summary statistics, I think this might be a bit confusing. If it is, we can just take a look at them one by one. But generally, what I did was for describe is going to describe like just the data set. So let's see here. I think, yeah. So here is describe. So the description of the numeric columns. So here you can see we have 150 data points. So for each we have, so we don't have any non-values. Okay. So the data points is 150, and the count for each column is 150. So this means that there are no missing values. Okay. And the mean value for each column, we have it here. Standard deviation, we have it here, the minimum value, and the quartile, which is up to 25, up to 75, sorry, up to 50, 75, and the maximum for each column. We also have it here. And for the categorical, so we have only one. So here, if you can see, we have 3, 1, 2, 3, 4 numerical columns and 1 categorical column, which is a species, right? So for this is for the second one. Okay. So describe include object. Sorry. Yeah. So here you can see the count is 150. So this means that there are no non-values. So we have 3 unique, unique values, and the one on top is setosa, and the frequency is 50. Actually, the frequency for all is the same. So 50, 50, 50. Okay. And this is for all. So here I have all. So for all, like it's pretty much the same actually. So here, it's just a combination of the two. Okay, so here you see none for the column of the, so it's for the categorical column because it's not a numerical, and here you can see non-values because for the numerical columns, because this is for identifying, or this is for categorical columns. Okay. Okay, so this is just for viewing the first 5 rows and this last 5 rows. So you can see it here. Head means head. If you don't specify any number, it's going to show you the first 5 data points, which you can see here. And if you just say tail and doesn't specify any numerical values, it's going to show you the last 5 data points. Okay, so that's just what it is, and just 5 random samples I just wanted to show here. So here you can see that. Okay, and then info is just to see the shape of the data set. So here you can see the shape and of course the data type of the value. So here you can see the range is 115 trees. The ID is from 0 up to 149. The columns are 5 columns. So this is basically the shape of the dataset, and the type is data frame, pandas data frame. And here you can see the data type of each column. Okay, so here for the lingus of the septa, it's float for the 4, and for the species it's object. So you can see it here. So we have 4 float or numerical values or numerical columns and 1 object column. Okay, and for the missing values, so this is for checking the missing values. You can see that there are no missing values. Yeah, so this is how we can profile a dataset. So we have profiled the dataset. So for this dataset, we do not have any non-values. If we had, we'd come up with a strategy to clean it and we would do it. Okay, but yeah, okay. Okay, I think it's better to just finish up, finish up and then come to the questions, I think. Okay, so let me just continue. So let's go to EDA or exploratory data analysis techniques. So we have actually mainly we can use we have around five, but the univariant, bivariant, and multivariant analysis. So for the univariant, so as the name shows, so uni means one, bi means two, and multi means more than two, right? Sorry. And so the univariate analysis just examines one variable at a time to understand its distribution and property. So we could use histograms to visualize the numeric of data spreads, box plots, and frequency tables can be used in order to show the univariant value or analysis of a single column at a time, okay? So Bob box plot identifies outliers and spreads. It detects extreme transaction amounts for sales and bank values, and frequency table just shows the count of an object or a categorical object. So this is just an example, but yeah. And for the bivariant, it just shows the relationship between two variables. Okay, so we could use scatter plot, correlation analysis, and cross tabulation in order to show the relationship between the two. So scatter plot assesses the relationship, and correlation quantifies the linear relationship between two variables, and the cross tabular is just for analyzing categorical relationships. And of course, multivariant is just more advanced, but it explores interaction among multiple variables. So this might be a bit confusing at first, but yeah, pair plots visualize or pairwise relationships, and PCA reduces dimensionality to high dimensionality data. So we will take a look at this as well. Outlier detection. So we need to always identify outliers, and if possible, identify their source or why that happened. So is it an issue related to the sensors, or is it an issue related to how the data was filled, or is it something else? So that's a good thing to look out for. So we normally check for outliers by using the z-score. So the z-score just identifies how much data point difference it has from the mean value, or for the yeah, from the mean value, how much far apart is it? So sorry. And inaccuracy range, so it flags values outside of 1.5 times IQR for quartiles. Sorry. And an example of outliers is if our data set is from $100 up to $1,000 for all of the entries, and one entry happens to have $1 million transaction, so it's likely to be an outlier. So we need to identify what it is and how it got there and flag it. Okay. And time series analysis is just for study of temporal data to identify its trends, seasonality, and anomalies. And we can use line plots and decomposition in order to do this. Okay. So missing value imputation. So imputation can be used in order to fix or in order to account for missing values, as well as in order to account for outliers. So for numerical, you could be using median or mean or forward fill or backward fill. And for categorical, you could use the mode, the one that has been repeatedly more repeatedly called or used. And of course, you could just leave missing. I'm sorry, give me 1 minute. Okay, I'm sorry about that. Okay, so yeah, and type conversion, you can actually ensure that the type for date time and categorical are like effective. So for instance, I don't think we have this issue for this data set for all, but for the future, we will see how this affects our analysis. So we can parse dates by using to date time, which is just a method under the pandas and so on. And derived features, so this also for the features. So for instance, binning continuous variables and encoding cycles, so months of the year, day of the week, so we can encode this as well. So actually, let's see some examples about these things, okay? Yeah. Okay. So we have seen the data profiling. So now let's move to the EDA, okay? So first thing that we should do is identify outliers. So for identifying outliers, so as I have explained earlier, so we're going to be using the z-score, which measures how many standard deviation each point has from its mean value. Okay, so it's going to calculate the mean value of the dataset, and it's going to measure or score how many standard deviation point each has from that mean. Okay, so that's just what z-score means. Okay, so here we have four numerical columns. So I just have them
Excuse me.
here. Yes.
Can you zoom the code a bit so that we can see?
Okay.
It's very
Yeah,
small.
yeah. Okay. Let me just close this one. What about one? Can you see it?
Yeah, that's absolutely great.
Okay. Okay. So here, for absolute value of z, if it is greater than 3, it's automatically flagged as outlier. Okay. So keep that in mind. So we're going to be computing the outlier detection for numerical values. So the numerical columns so are the theta and the beta lengths and widths. So we have identified those. Sorry. So here from the start, we are going to call the z-score method, and we're going to use absolute value method from NumPy in order to find the absolute the z-score. Okay, so as I've explained earlier, so the z-score is going to be that if the absolute value of the z-score is greater than 3, it's going to be automatically flagged as an outlier. Okay, so this is just what I'm just trying to explain what this code does. So it's going to find the z-score. So the z-score is just the z-score of the numerical values of the data frame. So DF is the data frame that we are working on. So for this data frame, we're going to take the column, the numerical columns, and find the z-scores and find the absolute value in order to assign it to the z-score. Yeah. Is that a question? Yes, Nabil?
Yeah, just wondering, are you using any kind of add-on to give the explanations as you hover over your code, or is that native to your IDE?
No, I'm not using anything. It's just okay for these things. Are you saying? Are you asking for these things? When I
Yeah,
hover on the
exactly.
yeah.
Exactly. Are you using it to add on? Are you using an add-on, or is it
No,
native
no,
to
no,
your VS
no,
Code setup?
no. It is native. It is native. No, it's not a setup. So whenever you call the method or the package, let's say PD, which is pandas and dots, so it's going to show you the methods, and if you go to one of them and do this, so it's going to load them. So if you hover over it, it's going to tell you what it's going to take, what it's all about, and so on. So actually, this is actually, let me show you how you can do this. Yes, Kudus? Okay.
How did you open the Jupyter files in VS Code?
It's just the file. So I just created the file.
Also, it just
You're
opens
gonna
it.
just, yeah, of course.
So Kidus, so what happens is in VS Code, once you save your first file as Jupyter with the Jupyter extension, it gives you the option to actually install Jupyter as an add-on to VS Code. So you have to do that the first time, and after you do that for the first time, then it will accept any kind of Jupyter notebooks natively. But for the first time, you have to actually install the add-on, and it'll actually give you a prompt to do that. You just have to save the file as IPYNB, and it'll do it.
Yeah, plus in addition to that, so you just need to install the kernel that's going to just run this, okay? So once you save it, it's going to come and just write something. And when you try to run it, let's say import so when you try to run it, it's going to ask you for a kernel. So you're going to select your virtual environment. So now, since I have already installed the kernel, it's not going to ask me, but for you guys, it's going to ask you for the first time. And once you install, it's going to work, just as I think Nabil said. So, Kudus, is that clear? Okay.
Yeah, it's clear. Thank you.
Okay. And for Neville, I was just saying, let's just define, sorry. Yeah, so let's just define a function and save it. And when you try to call it, so plot correlation and hover it, it should show you what's going to take and so on. Okay, so that's just what it is. And if you take a look at what's written here, is exactly what I have put here. Okay, so that's what comes when you hover over it. So it's not an add-on or anything. It's just how you write it. Okay.
Thank you.
Okay. So let's go back to the session. Let me remove this one. So here I'm gonna actually see if there are any outliers, and we have actually found one outlier. So one of the methods in order to handle these outliers is to impute them. So it's going to locate the outliers. So here, outlier flags, if you see them, so it's false, 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 but it's not going to show me. But actually, so it's false, but we have one true. So in order to remove that, I'm gonna find the outlier value when where the bool value is true, which means the value is an outlier, and I'm gonna fill that column or that value with the median. Okay, so that's what I did here. And if I run the above code again, we can see that that outlier is fixed or removed. So here, if you see it, it's going to be removed. So we have one here, but if you run it again, you're going to have 0 because we have inputted the median value in there. Okay. So that's how you can identify and handle outliers. Of course, you can also use a box plot in order to do that as well. Yeah. And now let's see the univariate visualization by using bar chart and multivariant, and of course bivariant by using scatter plot and so on. Okay. Okay. So as I have explained earlier, so univariant is going to see or take a look at each column individually. That's why it's called uni. So here you can see how it's distributed. So these values a little bit skewed to the left, I would say, but it's not that bad actually, but it's a little bit skewed to the left if you can see it. And here it's almost a perfect normal distribution. And here you can see it's not a normal distribution. Here as well, it's the same thing for the pental, but for the septal, it's normal distribution. We can go to the bivariant scatter plot by using scatter plot for actually here I am trying to look at the relationship or the bivariant analysis between the septal lengths and widths and the pental lengths and widths, but you can do actually cross. So you can see the septal lengths against the pental lengths and the width of the septal with the width of the pental. So here you can see how they are related. So the septal lengths and the septal widths for the three species, you can see them. So it's more of, it has actually more, I would say, direct relationship with each other. And here as well, they do have a direct relationship with each other, but here you can see that for the pental, the Setosa species has a very lower septal length and widths, but here it's more of a distributed. But here, of course, you can see that the septal length is less or shorter with a higher septal width for the Sentosa species. Of course, don't really focus that much about the analysis because it's about flowers and so on and so on. So it might not be that interesting for you guys, but yeah. And for the correlation, here I'm trying to look at if there are any correlation between them. So here you can see that we have the heat map, so here 111 means it's actually it's against itself. So it's 100% related. So don't mind this line. But outside of this line, so we can see that the pental lengths and the pental widths is very much related with 96% relation. But you can see also here that the septal lengths and the septal widths actually has a negative correlation, as well as the septal widths and the septal the pental widths also have a negative relationship. So there's some noise. So this is going to help you a lot in order to for you to identify any given relationship between the between your data, your columns. Okay. And finally, when we come to the final or the multivariant pairwise plots or analysis, I have used pair plots in order to see their relationship. So here you can see the septal widths against the septal. So here it might be a bit confusing. So the septal length is against the pental widths. I think I should have used some line between them in order to make it easy for you guys to see. But here you can basically see their relationship across all of the columns, right? So I think we have seen this, the pental length is against the pental widths, the pental widths against the septal length is the pental widths against the septal width. So it's basically against everything, right? Sorry. So yeah, so this is just the multivariant, which helps us see or take a look at how each just analysis of more than two or almost all of the columns. Okay. And finally, we have the categorical count. So this is going to help us identify if there are, if some categorical values are overrepresented while others are underrepresented and so on. But for our data set, or for our case, each or all of the species have 50 counts or 50 data points. So that's good. So yeah, that's what we have talked so far. So let me just finish up the slides and we can go to the Q&A. So of course, we can use advanced visualization techniques. Actually, the time series plot is not as advanced. Is that a question? Okay. Which means the rolling means seasonality and decomposition and temporal data we can find us by having a time series plot. Since this data set is not a time series data, yes, I think someone has their mic off. I don't know who. Of course, since this data point or this data that I'm using, since it's not a time series plot, I cannot show you this, but it's not that hard. We can actually take a look at it later on, or I can add it to the code and share it to you guys. And as a categorical comparison, we can actually have heat maps for categorical co-occurrence. Since the previous one, if you remember, for the example, we have seen the heat map for all these numerical values, right? So we can actually have that for the categorical as well. And mosaic plots are also used to compare categorical values, and specialty charts such as the windrows, bubble charts, radar poles for domain-specific insights. You can use those as well. And lastly, some like tips and best practices when it comes to data profiling and performing some EDA. So the first one is iterate. So always iterate. So it like EDA or data. Okay, so the data profiling can be a one-time thing, but EDA is not a one-time process. So you need to redo things, revisit, and arise different questions, ask different questions, and dive deeper into the EDA, into the analysis, and visualize them. So use plots to complement numerical summaries. So you have your numerical summaries, but it's not that interesting in order for you guys to share the numerical value. So I have found this, So it might not be that interesting for the stakeholders just to share the numerical values. So almost always try to use plots in order to show or in order to back up your numerical summaries, okay? And document what you have found. So always keep a record of your findings in a report or a notebook like I've used earlier, and validate. Of course, almost always you need to validate insight with your domain knowledge. So or additional data. So as I've said earlier, while working with the current project as well, please always be mindful of the errors that you may face while taking a look at the dataset, and try to find out or try to figure out why these things are happening and how you can address them or fix them, okay? And common insights from EDA are distribution. So from the distribution, you can use it to identify skewness. Is it left skewed? Is it normal distribution, or is it skewed, or multimodal data for transformation? You can see relationships. So detect strong correlation or unexpected patterns, like we have seen earlier. You can see a strong correlation or a very weak correlation or a negative correlation between columns. And outliers, from outliers, you can find some outlier values or flag anomalies for further investigation. So when you find outliers Of course, you have to remove them or you have to account for them or address them. But first, you need to understand why that happened. Of course, why that outline happened, and address it accordingly. Okay. And example, a strong correlation between two variables might suggest a predictive relationship. So so here from the example, you can see that like the pentyl lengths and the pentyl widths are very, very related. So from this, you can actually come up with a theory that or a predictive relationship that by only looking at the pentyl lengths, you could identify or guess or predict the pentyl widths. Okay. Yeah, so that's it for my side for the tutorial. So yeah, if you have any questions, I think we still have time. So let me address some of the questions that are here. Okay. So if you have any questions, please raise your hands and speak. For those of you who cannot speak, I can, and who has written here, I will try to address it. Okay, so please do respond. Okay. Yeah, Data Wrangler is a very good tool. You can also use that. Knowing about the data is important as the tools and the techniques. Yes, so that's why I have been emphasizing about like one of the thing or one of the mistakes that I see while people are working with data is they know how to use the tools or they know how to fix things, but they don't know about the data. So, for example, like I've said, so I'm sorry, I think someone is calling. Sorry. Okay, I'm sorry, guys. So, for instance, like I'm said, sorry, I think I should. So, I'm sorry. So I was saying, so like for instance, non-value or zero value does not mean that it should be imputed, right? Or it doesn't mean it should be imputed with the mean value or something like that. Okay, so you need to understand the data. You need to know about the data. You need to have at least some domain knowledge about the data. Okay, so for instance, for your current project, you need to have at least some domain knowledge about how the readings of the sensors, right? So, for example, okay, I don't want to raise this. I think it's better to come from you guys, but of course, yes, Nabi.
I was just going to say, to that point, I was dealing with one data set where I think where the data set should have been from 0 to 1, and I was noticing that there had a bunch of values above 1. So in that case, what I did was to all those values that were kind of outliers, I just capped it at 1. But for other data sets where I was missing some values in one feature, but I had a bunch of other features present, I used extra trees, which is a model to help impute the values, so that I wouldn't actually I wouldn't actually lose data, but I would still have, but I wouldn't be changing much of the distribution. So I guess, is that what you meant? Where it really depends on a case-by-case basis. It really depends on why the value is missing, and then is it best just to delete the observation, or is it best to kind of impute it.
Yes, yes. So exactly like you said. So everything depends on that specific data set's conditions, right? So as you have said, so it's a perfect example that you have mentioned in on the first scenario where the data set should have been from 0 to 1, but there were some values that were above 1. So you chose to make those above 1 come to 1 and continue with your analysis, right? So
That's
my
exactly what I
question to
did.
you, yes, that's what you did, but why? Why did you choose in order to make it or bring them to 1? Why not subtract? Yeah, okay. Please
Well,
continue.
because the reason why I made it 1 was in that case, it was a percentage, right? The percentages, right, they go from 0 to 1. And so it's just impossible to really have above 1. Now I know that anything above 1 must be invalid. And when you looked at the distribution of the data, there was a clear trend, which we call that as you had a higher, in this particular feature, as you went higher, the target was also going higher. And when I observed the correlation between the values above 1, they were pretty much following the same pattern. Now another thing that I could have done was I could have almost interpolated all the values that were existing to 1, but I feel like that would have been, that would have been too much manipulation of the data, and I didn't really have just cause. So for me, a nice compromise was just to cap it at 1. Was it a perfect solution? No, but it was the best one that I had available for me at the moment. Am I making
Excellent.
sense?
So, yeah, of course. Like I do understand you. So I just want you to like have this. So I just wanted everyone to have this sense of like questioning, right? So why did this happen, and what is the best solution in order to account for these things? Okay. So I love your solution, and I love your thinking method. So that's what I'm looking for. So even for the current project or for the current data set, I do expect you guys to do this similar thing. So some values could be outside of the range that you are expecting. So you need to identify, you need to understand why that happened and what's the best solution in order to account for that error or for that reading. Okay. So like always when you're working with the data, just like data points are not just numbers, so they are stories, right? So they are story points. So each data point is telling you a story. So you need to understand it, you need to hear it and understand it and act accordingly. So I do love it. So thank you for sharing your like process. So this is exactly what I was looking for. So I just wanted everyone to have this why mentality and like try to dig deeper. So of course, like imputing everything or reducing the values of like outside of the range to 1 could work for the one case, but it's not the ultimate or it's not the only go-to solution when dealing with other data sets, right? Nabil? So
Yeah,
for
that's not, no, that was
each issue,
definitely specific
yeah,
to that issue. That was definitely a specific
yes,
solution for that issue. It was the best one I could come
exactly,
up with. But there was
of course.
another, an exact same data set. There was another feature, right? Where there
Yeah.
was no real reason why we had null values, but I was missing 30% of my values. So what I did in that case was I used extra trees to to look at all the other features and impute the variable and impute it based on using extra trees, which is a ML model. And then
Yeah.
the result of that was I did bivariate analysis before and after. Now looking at my distributions before and after, I just wanted to make sure that I didn't change my distribution too much. And when I noticed that my imputation didn't change my distribution too much, I decided I did my job well. Because
Exactly.
I imputed, the purpose of my imputation in that case was to not give up 30% of my data.
Of
And if
course,
I
that's
could
it.
impute without affecting my distributions overall, I considered my job well
That's
done in
it.
that case.
Yeah. It's a well done. Yeah. So that's exactly what I mean. So thank you for sharing. So everyone, I think these examples, the two examples, have actually helped. I think helped me complicate my concern when working with data. So thank you, Nabil. And I hope everyone also understands this. So try to understand the datasets, try different things, work with different things. And as I've said, EDA is not a one-time thing. So you need to iterate it. So you need to come back and go forward and, do these things. So yeah, this is just my recommendation. Okay, so back to the questions. I don't know about this, where these things can. Does anyone have the lecture? We have the lecture before. So, Bamnet, I'm not sure, but if you are talking about the tutorial session that you guys had in the morning, I think it should be already shared. The YouTube should already be shared. Okay. Yes, the code also will be shared. I will also share it on Slack. Yes, I will share it. Yeah. Could you please? So bivariant, multivariant, and univariant is just for analyzing one, two, or many variables. So bivariant is just to analyze two variables. So here you can see that this is sort of for the multi. So here you can see that we are trying to analyze pental lengths and pental widths. So here it's called bivariant. Okay. Time series, I think we can, yes, Nabil?
I'm sorry, I just wanted to ask, would it be possible that you share us some resources on validating our imputation methods, or just seeing that just make sure that we did a good job and that we're making the right choices? Would you be able to share some techniques for that?
Yeah, so basically, so for imputation, what I would look for is, so there are some, of course, they don't always work, but some general rules when imputing. So by taking a look at the distribution of the data, if it is skewed to the right, it's better to use a median value, and if it is skewed to the left, it's more better to use the mean value, I think. Like I will share it, come back to you on Slack, but basically these are the general rules. But of course, like it does not work always, right? So it depends. So as you have said earlier, it depends on the data. So what I would advise is try the imputation method that they have. It could be imputing like the mean value, the mode value, or the median value. Or it could also be forward filling and backward filling. For instance, if it is time series value, and if the time series value, if you take a look at it and it has a direct relation, you can actually use forward and backward filling, or things like that, if the change is not that much, and so on. So it's not like a general truth thing, right? So it depends on the data type and like the domain knowledge that you have about that specific data set. So as a general rule, you can use that. Yeah. Okay. For time series data, so what I mean is, so you also have, in addition to the data set, you also have the time that the data point was taken. So you can actually relate that with the time. So for this one, I think you guys have a time series data set. So I don't know what you mean by keep, but yeah. Yes. Yes. So I think I have explained each line of the code. So this is just CNS dot scatter plot for plotting the scatter. So here it's just CNS dot histoplots, which is histogram plotting. I think I have explained this every line, so it's not that much. So SNS scatter plots. Here you will give you the data point, the data set. So sorry, which is the data frame. What you want to show in the x value on the x-axis, and what you want to show in the y-axis, and what the hue is going to be. So the hue is just what you want it to differentiate by. Actually, yeah, yeah. And the title and plot show is just to show the plot. And here again, it's just correlation. So it's a heat map. Correlation is between the numerical values. So here you can just say heat map, and for the data set, you can specify the numerical values of the data set, and unknown, and the coloring, and to use a square or not, and the title and show is just to show the plot and pair plot. So it's just the same thing. So we have the package and the method, and yeah. Okay. 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 Yes, Aisha. Okay, good. Ndalo, I hope you guys took something to you guys from with you guys from this session. Can we get the recording of the YouTuber? Yes, Barakat? Yeah, I think it was a mistake. So you will get the YouTube video, I think, within 2 hours. Oh, so the data, since it's a very like you can find this data set from Kaggle or anywhere else. Plus, it's already you can find it already loaded on Seaborn. So CNS dot dataset, and if you specify the name of the dataset, it's going to load it for you guys. Actually, I have another one here, which is penguins. So here, actually, it's pretty much the same. It's just beard lengths, depths, flipper lengths, and body mass, and so on. So I just loaded this data set from the SNS or the Seaborn. Can share best practice for organizing folder and file structure with his data profiling and ADA. So it's not a different thing. So always have one structure that we have already shared with you guys. I think we have shared it on the challenge document. So try to follow that structure. And here, if you can see that I have my notebooks under the notebooks folder, but I do not use any additional or any external structures. Okay. Can we get the code in the repo link? Of course, I will share the notebook, but I think it's better since this actually this is a continual from the yesterday's session. What I will do is I will push it, and I will share the link. Okay. Okay. What's I got? So okay, Kyle, okay. I think it's answered here. Okay. Okay, Alabacho, I think this is a great question. So yeah, when you take a look at the correlation or the heat map, you can see that some of them have high correlation, some of them have low correlation, and some of them have a negative correlation. So what does this mean? So a high positive correlation means that the higher the pental length, for example, for this case, the higher the pental length, the higher the pental width. and so on. And here you can see that it's a lower negative, so the spiral lengths and the spiral widths are negatively rated, which means so well, when one becomes so, if the septal length is longer, the width is a bit like narrow, you can say. And here as well, so the pental length, if the flower's pental length is higher, you can expect, or if the septal width is like wider, you can expect a shorter pental length. So sorry, I think I have missed. So if the septal width is wider, you can expect a shorter pental length and so on. So this is just for this tells you the relationship between the columns or the variables. So that's a good question. Can you repeat text or say it again? Nabil, okay. Let's collect the CSV files. Okay. Okay, I think it's actually been answered. Tutorial. Does the target variable must be categorical? So I think you mean numerical, right? Support the target variable to be numerical. Yes. So in order to have this analysis, it's better to have, so especially for scatter plot and so. So of course you can work with the count, but that's not going to be that interesting. The count of the categorical values, but that's not going to be that interesting. So yes, it should be a numerical value. I mean, for relationship between the target and the feature. Correlation between the target and the feature. No, for this case, it's not, but of course you can make it. So you can just extract for that specific category and work with that, or just for this case, I just worked with all of the data set. But of course, you can do that as well. Can you also explain? So this is the correlation matrix, which I just explained. Miju, I think. Okay, so is that clear, guys? Is everything clear? Any questions? Anything that's not clear? I mean, the last one. So the last one, you mean here, this one, this is just a count, the last one. This is the count. Miju. So this is a count. And this is for multivariant, it's just for seeing the relationship between more than one, more than two variables. So which one do you mean, the last one? Actually, let me just think. I can remove this too. Yeah. Okay. So I will share the notebook. Actually, I will share my GitHub link inside the slides and share the slides right now, okay, after the session is over. So for the multivariant, it's just, so here you can see, for example, how the pental width relates with the septal lengths, the septal widths and the pental lengths, and here you can see how the septal length is related with the the pental length, the septal width. And here you can see how the septal width relates with the pental width and the pental length, and the pental length with the septal width, and so on. So that's how it's related. So this might be a bit advanced, so I don't expect you to actually implement this for this project, but for the future, we will see it. I think maybe if it is a bit confusing, don't be discouraged. Don't worry about it. So you can leave the multivariant. But basically, that's how you do it. Okay. Okay. Good. Okay, guys. Thank you so much for joining. I think you can end the session here. Any questions, anything that's not clear, please try to contact me on Slack, and I will be there to answer. Okay. Thank you, guys. Thank you for joining, and have a great day. Bye.